Hi there, my name is Dimitris Haralambidis, and in this video, which is part of a greater series of videos dedicated on the AP Precalculus syllabus, we will continue our whole exploration on Unit 1 by examining a graph of a function and its extremas. Here in the image in front of us, we have the graph of a function. And you have seen that the image itself names two specific points. It names this as a local maximum, and this as a local maximum as well, and this one as a local minimum. We could clearly understand that in one, where we're supposed to take notes, and remember, I don't know if we have mentioned that earlier in the previous videos, but we are practically going over one booklet I created for my class in school, which is focused again on the AP Precalculus. And here in these videos, we go over that booklet together. So here I would have some notes for my students. In a local maximum, the function goes from, you can see, we have a local maximum. Let me call these points as A and B. So based on monotonicity, we can see that in a local maximum, the function goes from increasing to decreasing. Increasing, decreasing, and up here, it does the local max. Similarly, in a local minimum, the function goes from decreasing to increasing. And obviously, it's too easy for someone to visualize it. From decreasing, we go to increasing, and this point is called local minimum. We will not mention anything about the instantaneous rate of change. We will see it later on. But I want us to understand the difference between the local and the total maximum or minimum. The local maximum or the local minimum are just the points where you see that the graph does this in a local maximum. So this vertex here is referred to as local max. Similarly, the local mean is the point where the graph does this. These are locals. Regarding the totals, we would say that the biggest local maximum, the biggest of all, would be called total maximum. Total maximum. Similarly, the smallest local minimum is called total minimum. So we have four different types, locals and totals. When I was in your age, my teacher then asked, could a local maximum be smaller than a local minimum? Take some time. Could a local max be smaller below a local minimum? Yes, because we refer only at locals. So we have this local maximum, which is here. But then, for some reason, the graph could be going like this. And this one is a local minimum. No one ever said that local maximums should always be placed above local minimums. Local max is just the point where the graph does this. Local min is just the point where the graph does that. So, yes, this could be, under certain cases, or irrelevant to anything that has to do with a function, could indeed be below a local minimum. However, the total maximum is always at the top. The total minimum is always the smallest value. What happens to the graph's endpoints? Well, here is another thing. Total max and total mean are also considered to be the points at which the function at the endpoints of the interval, at where the function is defined. So, This one as well could have been this one here in our graph, this thing, could be as well be a local mean, and this one could as well be a local mean. Sorry, let me erase that. Local mean and local mean. So what do I want you to keep from this video? Local max is any point at where the graph does this curve. Local mean is the point, the vertex at every smiley part of a graph. But the endpoints of an interval at which a function is defined can also be local minimum or local max, depending on the monotonicity of the function right next to these endpoints. The biggest of the local maximums is called total maximum, and the smallest of the local minimums is called total minimum. That's all for now. I hope I really made it easy for you to understand. If you found this video helpful enough, do not forget, like it and follow me, subscribe to this channel so that you don't miss anything new. As always, thank you for watching, and I'll see you in one of the following videos. Have a great day.